Hello, my name is Aaron Park, and this is 7th grade, lesson 35. For our first question, we have to find the area of a tile, the width of which is 8 inches, and the length is 12 inches. So first of all, let's draw our tile. A tile is square or rectangular, in other words a quadrilateral, and we know that the area of a quadrilateral is length times width. Luckily for us, both length and width are given. Length is 12 inches, and the width is 8 inches, giving us 12 times 8 equals our area. 12 times 8 is 96, and we can't forget our units, which is inches squared for area. This is answer choice D. Now we have to find the volume of a cube, the edge of which is 5 inches long. So let's draw a cube real quick. Something like this. In a cube, just like a square but 3D, all edges are the same length, and this length is 5. So we have 5, 5, and 5, along with all the other edges. The volume of a cube, or any rectangular prism, is the length times the width times the height. But for a cube, the length, width, and height are all the same. I can mark that for you right now, where green is the length, blue it's the width, and finally red will be our height. These are all 5, which means that volume is equal to 5 times 5 times 5, or 5 cubed. 5 cubed is 125, and volume is in cubic units, in this case inches. This answer is D. Now, what is the surface area of a matchbox, the length of which is 3 inches, the width is 2 inches, and the height is 1 inch? A matchbox is a rectangular prism, so let's draw that out. But sadly, it's not a cube. However, they do give us the length, width, and height. The length, it doesn't really matter which ones you mark, as long as you mark 3 different axes. I would say this part is the length, this is the width, and finally the height is the smaller side. Now, surface area is a little bit more complicated than volume. Surface area is, as the name implies, the area of the surface. Or to put it more carefully, if we add up the sum of the areas of each face, we will get our surface area. You can think about it kind of like this. The volume is the space inside, which means kind of like how much water would you need to pour into a cup. However much water it is the volume. Or instead of a cup, a box, or in this case, the matchbox. But surface area is a little bit different. Surface area is, what if you wanted to paint the outside in paint? A completely new outside. Or in other words, you're painting the surface. How much paint would you need? That's kind of like the surface area. Now, with that out of the way, I kind of mentioned this earlier, but to calculate surface area, we're going to add up the areas of all the faces. Now, there are going to be 3 different types of faces, but 2 of each type, because you can see the 3 different types on this side, but there's going to be 3 more on the other. There's this smaller rectangle in the front, which is 2 by 1, but there's another one on this end, right over here. Similarly, there's going to be one that's 3 by 1 on the side, and the tops and bottoms are going to be 3 by 2. Now, find the areas of each of these types of faces, 2, 3, and 6. Add these together, 2 plus 3 plus 6 is 11. And then multiply by 2, because there's 2 of each face, to get 22. If it makes more sense, you can multiply by 2 before adding them up, but you should end up with the same answer. 4 plus 6 plus 12 is still 22. Now, the units of surface area, it's in the name, area is square units. So 22 inches squared, which is C. Number 4 asks again the surface area, but this time it's of a cube. A Rubik's Cube to be exact. So let's draw our cube. 3, 3, and 3. The edges are all the same length. Luckily for us, if the edges are the same, that means all the faces are the same. They're all going to be a square. That is 3 inches by 3 inches, which is 9. The area of a face is 9. And then, how many faces does a cube have? Well, if you've ever solved the Rubik's Cube, you would know that that is 6 faces. Alternatively, you can think about it as 1, 2, 3, and then 3 more on the other side. Or if it helps, you can visualize one of those die, or in plural, dice. A dice can, if you roll it, have 1 pip on the side, or all the way up to 6, because there are 6 different sides on a cube. 9 times 6 is 54 inches squared. The answer is B. Now then, I'll leave the rest to you, and then we'll move on away from geometry to factoring. Factor each polynomial. You'll note that these polynomials are a little bit special. They only have 2 terms, so they are technically a binomial. Another special thing about them is, while it may not be instantly apparent to some of you, you'll note that both terms are squares. Specifically, x squared, which is, as the name implies, x squared, and 25, which is 5 squared. When you multiply, or when you have 2 squares in a polynomial, and you're subtracting them from one another, that is called a difference of squares. So if you have a square and another square, and you subtract them, in other words, you're finding the difference of 2 squares, right? If you remember, just like the sum for adding, it's the difference for subtracting. Well, you can factor a difference of squares as such: a plus b times a minus b. It's that simple. So that means first you want to figure out what is a and b. X squared is a squared, so that means a is x. And b squared is being subtracted. So it's not negative 25, that's b squared. It's just 25, that's b squared, which means b is 5. So we know our 2 numbers, a and b, and a and b. And then we just write the signs, which is one of them is adding, one of them is subtracting. That's our final answer. A difference of squares is just that simple to factor. Number 2 is just like number 1. Let's look at number 3. It might not be instantly apparent. Well, 4 we know is 2 squared. But what about 81c squared? That's a bit tricky. If you ever have trouble, you can grab the term and isolate it somewhere off to the side on a piece of paper and square root it. Square rooting it gives us 9c, which is what we're looking for. Alternatively, you can note that 9 is 81 square rooted, and c is c squared square rooted. In other words, that means 9c squared is 81c squared. You can treat the coefficient and the variable almost as separate. They're just being multiplied at the end. Now with our two terms, we can simply repeat what we did above and write our two equations, or write our two binomials multiplied together. 9c plus 2 times 9c minus 2. Repeat for these other ones. None of these should be too challenging except 5. 5 is tricky. You'll note that there is a negative 3 here. And what do we know about negative numbers? Well, you can't square root them. They aren't a square of anything. So that might be puzzling. How do we solve this problem then if it isn't a difference of squares? Well, it kind of is. It's just being hidden. We learned about factoring generally, and in this case, if there's some common factor, it's important to factor that out separately. And in this case, 3 is a common factor. We can factor out 3, but I'll choose to factor out negative 3. Negative 3 being factored out, these are with m squared minus 16n squared. And that should be an obvious difference of squares. M squared and then 4n squared. Now that it's in this force, I'll leave it up to you. Thank you.